to find critical points of a function, you first need to take the derivative. So I'm going to go ahead and do that. The derivative of 4x is 4. The derivative of sine of 4x is cosine of 4x. And then the chain rule will pop out a factor of 4 due to the derivative of that inside function. Okay. Critical points are the values of x that cause this to equal 0 or to be undefined. Well, I've got some good news. There is no value of x that's going to make this undefined. So all we need to worry about is the value of x that caused this thing to equal 0. That means I'm going to subtract 4 from both sides and then divide by 4, giving me cosine of 4x equals -1. Now, it might be difficult for you to solve this trigonometric equation, especially with that weird 4x there. So what I'm going to do is I'm going to simplify a little bit. Let's just pretend it was cosine of x. When is cosine of x equal to -1? Well, if you know your unit circle, x equals pi solves this equation. But you can also go around the unit circle multiple times. So x equals pi works, but so does 3 pi, and so does 5 pi. So with that in mind, I have a few values, and I could even keep going and say 7 pi, and so on. These values of x solved cosine of x equals -1. But remember, this is cosine of 4x. So what I need to do to each of these values is divide by that factor of 4. We're going to say divide by 4, divide by 4, divide by 4, and divide by 4. All of these values of x are potential solutions to this equation. So these are our critical points. But we need to figure out a way to write this in a concise way, because obviously this could go on forever. I could say 9 pi over 4 and 11 pi over 4 and 13 pi over 4 and so on. So the good way to write a concise odd pi over 4 is by saying x equals 2n plus 1 times pi over 4, and these are your critical points.